Hello and welcome. I'm Jimmy Haight. I'm a product development engineer here at Semicore. In this presentation, I'm going to cover who Semicore is, what exactly Semicore does, and our approach to customers. Semicore is made up of people with the skills and experience to provide solutions to process equipment needs. Founded in 1996, Semicore is a manufacturer of vacuum coating equipment for industry and R&D groups. Our primary products revolve around advanced PVD films using sputter and evaporation techniques. Additionally, we collaborate with customers on specialized applications and processes to develop custom solutions. The equipment Semicore produces is used in a wide variety of industries, such as MEMS, solar, hard coatings, automotive, medical, semiconductor, defense, optics, science, and education. The concept is simple. Listen to the needs, goals, limitations, and ideas of the customer. The execution is a bit more complex, however. Take those considerations and turn them into a solution that fits the need. Either employ one of our highly configurable existing models, modify one of those designs to suit, or start from scratch entirely. On average, about half of the system sales are indeed custom applications to some level. The follow-through is just as important, however. We continue to work with the customer to ensure that the system is filling the need and provide additional development and support as required. From training and upgrades to service contracts and spare parts, Semicore continues to partner with our customers. So let's have a look at some popular system models. The SC450 is a confocal sputter platform designed for research and small-scale production applications. They are full-featured and configurable with many process options. Scaled up from that, we have the Porous system. This is our most popular platform as it can be configured for many applications. From confocal or parallel sputter to evaporation, this form factor is well suited for research and production. As you can see, they may be used in a standalone batch system or in a cluster tool configuration, allowing up to 5 process modules and full semi-standard wafer cassette operation. The tri-axis models are specifically designed to be configured for vertical sputtering, up or down, or horizontal sputtering. This provides the ability to select the best process orientation for your specific needs. The 8600 system is designed for tribological coatings commonly used where high lubricity or hard coatings are needed on 3-dimensional parts. More on that later. The SC1500 inline sputter system. It is intended for high throughput applications. The modular design allows for multiple process chambers to fill the need. It's like a cluster tool, just in line. Here's a Porous system configured for evaporation with high-pressure reactive deposition. The SC3500 is a large-scale evaporator designed for large substrates or long-throw deposition common in optical coatings. Now let's discuss some specific applications where Semicore helped develop a solution for the customer's problem. This customer needed to achieve dense conformal coatings on textured insulating substrates. This poses a problem when you cannot bias the substrate for density control or utilize heat to promote adhesion. It is especially difficult with materials like sapphire, alumina, or perovskite. By using high PIMs, we overcome these obstacles. We get better adhesion through ion energy control, trading ion energy for thermal energy. It gives us control over the coating structure like density as well as provides good conformity. That enables trench filling and coverage for other 3D surface features. This method also allows for shallow implantation of mixed ions into the surface of the substrate. Here, the customer was looking to develop durable coatings with color control for a specific application. The key was finding a solution that provided a wide range of control for color and material properties. Again, high PIMs was employed as well as more typical pulse DC sputtering. That said, a vital part of the solution was the integration of a closed-loop control system for optical emission and target voltage. This supports metal-to-metal nitrides or oxides and in between for color development. Also, controlling the partial pressure of the reactive gas to affect the chemical composition of the coating. This application called for high volume production, so accelerated deposition rates and fast process times were required. This customer wanted to explore different tribological coatings for the first time. The expected application required significant flexibility in the substrate tooling as well as the process technology. This required RF or DC for some films and once again high PIMs for others. There were many hurdles to overcome for the success of this customer, not the least of which was to complete the effort during a global pandemic. Yes, this system was designed, produced, tested, and delivered while this country was in a lockdown. We performed both a factory acceptance test and a site acceptance test virtually, not unlike what we're doing here today. In this situation, the customer needed to scale up a peculiar process requirement that to this point they had not been able to achieve. The goal was to sputter a very porous material, then sputter a different material to fill the pores. They had two different variants, one of which would require them to etch back the top layer and then repeat the process a few times. Our approach was to replicate their small-scale version, but found a concern. This scale-up would require very high pressures during sputter deposition to achieve the porosity desired, in some cases as high as 400 millitorr. The high pressures created dark space issues for the cathode as well as other areas of the process. We utilized some gas distribution techniques as well as unique dark spacing that would also allow for normal deposition pressures down to 3 millitorr. Other process requirements called for biasing the moving substrate during the scan, as well as dual cathode co-deposition for a scanning layered effect. This system had a lot going on, but the process results have passed all expectations. This customer needed to coat several different large three-dimensional parts with many features cut in it. Some of those features had very tall aspect ratios, making it difficult to get deposition where it needed to go. Utilizing some creative filament evaporation techniques initially pioneered by the customer, we modified the approach and added high voltage DC bias on the part. Very high voltage. That coupled with adding an inert non-reactive gas and controlling the process pressure much higher than typical evaporation processes do, we were able to achieve the coating requirements with better than expected homogeneity. The high voltage DC bias power source was also used to plasma clean the part prior to deposition in order to provide better adhesion. Total coverage was critical to prevent oxidation on the surface of the part in the following stages of its application. Verification tests showed that this novel approach proved to be 100% effective. Semicore does unique well. The engineering team has developed novel solutions with and for our customers' special problems. This part of the presentation should truly be one of its own. I could provide a pile of examples of square peg needs where only round hole solutions were available until the customer and Semicore collaborated to create an entirely new shape. The key is how Semicore engages and develops a solution, then executes. Using today's advanced engineering tools, we provide detailed concept. Once everyone agrees on the approach, we build. This starts with system documentation. From electrical design and assembly drawings to functional design layout and bill of materials, this is how it gets done. System control is just as important. Many people see the GUI as the system. So many users spend so much time in front of it that it's critical to give them control, flexibility, and data to create the process needed. Our control software includes full auto processing from start to finish. Designed for a production environment, there are key features to support: lot tracking, real-time data charting, and data logging for process traceability, simplified recipe development, user access control, consumable materials tracking, as well as maintenance tools and manual control with intuitive protection. Even the custom systems get this level of control. So what can Semicore do for you? We have a variety of existing proven system platforms. We have extensive engineering capability with the integration of new technology and process concepts, and we collaborate well with our customer for unique requirements. Thank you for your attention. If you have any questions or are interested in contacting Semicore to see how we can help provide a solution for you, please do.